Let's solve this triangle with 3 known sides. Now I know that I need to use the law of cosines for this triangle, but why? There are actually 2 cases when you want to use the law of cosines. The one is the one that we saw first, and that's our side case. The second case, it's my side angle side. The angle that I know happens to be right in between the 2 sides that I know. There are actually 3 versions of the law of cosines depending on what information you've got or what you're looking for. The law of cosines that involves angle A looks like this. So I've got A squared is equal to B squared plus C squared minus, and I call this my fudge factor, this is going to be 2 times B times C times the cosine of angle A. There's a similar one for angle B. So this is going to be B squared is equal to A squared, the other 2, plus C squared, minus 2AC times the cosine of angle B. And finally, if you're involving angle C, it's going to look a lot like the Pythagorean theorem. C squared is equal to A squared plus B squared minus that fudge factor of 2AB times the cosine of angle C. Let's go ahead and use this version of the formula to find angle C. Now I'm going to plug in the values that I know for A, B, and C, those sides C. So that gives me 10 squared is equal to A squared, so that's 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of angle C. So I want to do 100 minus, let's go ahead and subtract the 7 squared and subtract the 5 squared. So minus 49 minus 25 is equal to negative 2 times 7 times 5. 7 times 5 is 35, times 2 is 70. So I get negative 70 cosine of angle C. If I simplify the other side, I end up with 26. So I get 26 is equal to negative 70 times the cosine of side C. I'm going to divide both sides by a negative 70. So that leaves me with a negative 26 divided by 70 is equal to, leave yourself a little bit of room there, the cosine of C. And I left myself some room because I'm solving for C. I'm going to undo that cosine by applying a cosine inverse. And whatever I do to one side, I better do to the other side as well. So I've got a cosine inverse on the left and the right. I can cancel our cosine inverses and I end up with C on the right-hand side. Let's go ahead and put that into our calculator to get the other side. I'm going to start by going into my mode to make sure that I'm in degrees. You'll notice if I arrow down to the 4th row, degrees is highlighted. If it isn't, go ahead and move your arrow over 2 degrees so it's blinking and then hit enter. Now I'm here, so I can hit second followed by mode to quit, and I'm ready to type in that cosine inverse. So I want to hit second and then cosine to get that cosine inverse. Inside those parentheses, I want the little negative down at the bottom, so negative 26 divided by 70, and that cosine inverse is 111.8 degrees approximately. So now we've got our angle C, and that's 111.8 degrees. So angle C is done, 111.8 degrees. Now next, I can find any of my other 2 angles, and to do that, I could use a law of cosines, but I actually think the law of sines is simpler. So I'm going to go ahead and use a law of sines next. I want to combine my known information. So I've got an angle C and a side C both known, and I can combine that with any other pair. I'm going to go ahead and pick up A and A. So the fractions that I want for the law of sines combine A and A, so the sine of A over side A, and C and C, so sine C over C. Putting in my values that I know and don't know, I end up with the sine of A, which I don't know angle A, but I do know that side A is equal to 7. And then over there for C, I've got the sine of that angle that we just found, 111.8, divided by side C, which is 10. Remember, I'm solving for that sine A. So I know that I want to cross multiply by the 7 to isolate the sine of A. So I get that the sine of A is equal to 7 times the sine of 111.8 degrees, all divided by 10. I really want A by itself now, so I'm going to apply a sine inverse to both sides. So a sine inverse there and a sine inverse. I'm just going to squeeze it in there. Now on the left-hand side, the sine and the sine inverse cancel each other, and I know that sine inverse can only ever give me an acute angle less than 90 degrees. Well, I know that my remaining two angles are both acute, so I am good to go. So I'm going to end up with A on this side, and then that sine inverse is going to need to go right into my calculator. I'm just going to clean it up a little bit here. So we've got a clean formula to work from. Second sine is going to give me that sine inverse, and then I want 7 sine of 111.8 degrees. Close your parentheses, and then divided by 10. I'm going to close my parentheses here as well, and I end up with angle measure A, which is about 40.5 degrees. So I've got that angle A is about 40.5 degrees, and I can go ahead and put angle A right here. That leaves me with just one angle left to find, and that happens to be angle B. Well, I know two angles, so I'm going to use the fact that the sum of all of my angles in my triangle adds to 180. So I'm going to take 180 and subtract the angles that I know, and that's going to be angle C and angle A. This is equal to angle B, and I get that B is 27.7. So 27.7, and we have found all of our values. Now I've got two more examples for you. The last one is super important, so let's get right into the next one. This is the next triangle that I want to solve, and I notice that I've got a side, an angle, and a side. So this is my side angle side case. I do want to use the law of cosines. Now I always try for the law of sines. I think it's a little bit easier, but I would need an angle and the opposite side to be known. I do not know those. So the law of cosines it is. I need the formula that involves angle measure A. So that formula is A squared is equal to B squared plus C squared minus 2 times those last two letters, so B times C, times the cosine of angle A. Let's go ahead and plug in what we know. The only thing we don't know in this formula actually is side A. So I've got A squared is equal to B squared. That's going to be 9 squared plus 8 squared minus 2 times 9 times 8 times the cosine of angle A, which is 122 degrees. Now I can put all of this into my calculator, and I can also take a square root of all of that, and that is going to give me side A. So I'm going to take the square root of this. So I'm going to do second and then my squared button to get the square root. And then I want 9 squared. Let's use the x squared key again, plus 8 squared minus 2 times 9 times 8 times the cosine of 122 degrees. I'll go ahead and close my parentheses, and I get that side length A, which is 14.87. I'm rounding to 1 decimal, so I'm going to call that 14.9. So A is about 14.9. This is side A, 14.9. Now from here, I could use another law of cosines to find either angle B or angle C, but I think the law of sines is easier. So I'm going to use the law of sines, and to use the law of sines, I need two known values, an angle and a side opposite. Now I've got A, and then I can use any of the other two. Let's go ahead and use angle C and side C. So I'm going to put together the law of sines with a sine of A over A is equal to the sine of C over C. Let's go ahead and put in the known values now. That's going to give me the sine of angle A, which is 122, divided by side A. We just found that to be 14.9. Angle C is what I'm solving for, so I'm just going to leave sine of C there, but I do know that the side C has length 8. Now remember, I'm solving for C, so I'm going to start by isolating sine C. I'm going to cross multiply here by 8, and I get 8 times the sine of 122 divided by our 14.9 is equal to the sine of C. Now I moved that over because I know I want to apply a sine inverse. So I'm going to apply a sine inverse here, and I want a sine inverse on the left as well. Now those two sine inverses on the right-hand side are going to cancel each other out, and I know that I'm good to get my angle measure C as long as it's an acute angle. That's all that sine inverse can give me, less than 90, and it is, so I'm going to be great. So this is going to give me angle C. I just need to put all of that into the calculator. So I want sine inverse, so second of sine, parentheses are there, so 8 times the sine of 122. I'm going to close that parenthesis and then divided by 14.9. Close my parenthesis and enter, and I've got my angle measure C, 27.086. Let's call that 27.1 degrees. So angle measure C here is 27.1 degrees. Do you see all that we've got left? I have all three sides, and I've got two of my angles. So the only thing that I've got left to find here is angle measure B. And we're going to find angle measure B using 180 for the sum of our angles. To find that missing angle, I'm going to take 180 and subtract the angles that I do know. I've got that 27.1 now, and I've got 122, and that's going to leave me with my missing angle measure. And I get 30.9, and we've got this triangle solved. Now this last example is a super important one. It happens to be our side case, so I know it's a great one to use our law of cosines with. I've got side A, which is 11. I've got side B, which is a length of 4, and then side C, which is a length of 3. Let me go ahead and label each of these here. A is equal to 11. We know we're going to want the law of cosines. B is equal to 4. This is going to end up being a really special case, which is going to make our life super easy. Now I know I need to solve for one of my angles. Let's go ahead and solve here for angle B. So I'm going to put the law of cosines together that involves angle B. So I want B squared by itself equals A squared plus C squared minus 2 times those last letters times the cosine of angle B. So putting the values in that I know, I've got B squared, so that's going to be 4 squared is equal to A, which is 11, so 11 squared plus 3 squared minus 2 times 11 times 3 times the cosine of angle B. 4 squared is 16. This is going to be 121 plus 9 minus 2 times 11 is 22 times 3 is 66. So minus 66 cosine of angle B. Now I know that 121 and 9 is equal to 130. So let's go ahead and subtract that 130 from both sides, minus 130. We end up with negative 114 is equal to negative 66 cosine of B. Now, my goal is to get to B. I'm going to start by isolating the cosine of B. You might see where I'm headed. If not, that's okay. I'm going to divide both sides here by negative 66 by negative 66. So what I end up with is 114 positive over 66 is equal to the cosine of angle B. Now this number, 114 over 66, is larger than 1. Cosine, if you've done your cosine wave before, cosine can only be, it's a fraction. Those cosine values can only be between negative 1 and positive 1. A cosine of 114 over 66 just isn't possible. And if you happen to be taking an exam and you just don't recognize that, that's okay. Let me get rid of this. Let's say that you attempt to do your cosine inverse of 114 over 66. The cosine inverse on the other side is just going to leave you with angle B. And when I put that cosine inverse into my calculator, we'll do second and then cosine, and then I want that 114 divided by 66. Enter, and I end up with an error domain. It is not possible. I'm going to take a second look at this. So B does not exist. B is not possible here. Well, remember I said that I had that triangle with sides 11. So this is side A is equal to 11. I had 11. B was equal to 4. And side C was equal to 3. There is no way that I can form a triangle with these lengths. 11, 4, and 3 are never going to match up to a triangle. Had we recognized that we could not form a triangle in the first place, we could have skipped all of that math that I did up above. So I really want you to think through that side case. Is it even possible to construct a triangle? In this case, it isn't. So I'm going to say just no possible triangle. This is my answer. So no possible triangle. You are doing so great. Take a look at this video next.